So, welcome and really glad to be able to present today about topics. So, the title of my talk is Getting Off the Scan and Fix Hamster Wheel with Generative AI, right? So, let me just walk you through what I mean by hamster wheel and how we can get off it. But first, a little bit about myself. So, I'm Asankhaya. I'm the co founder of Patched. I've spent almost the last 15 years of my professional career working in AppSec. I worked for a variety of vendors, Microsoft, Veracode, CA, done a couple of startups, SourceClear, SecureAid in the past. And I also built a lot of free and open source tools. So if you've right from code analysis tool, cat.net tool back in the day, to Gram Test, Bot-Wolf4j, the SCA agent, and so on. And as I've spent primarily my entire professional life building security tools for developers, if you work with developers, you'll realize that when you go and talk to them, they'll always have this conception in the mind like, hey, security, I mean, that's surely somebody else's problem, right? I don't have time. And it's not entirely their fault. I mean, if you look at how most of software gets built, it's always rushed under deadline, and then even if they want to do something, they generally don't have enough time and bandwidth or the mandate from stakeholders to do it, right? So their primary goal is to, hey, can I make this feature? Can I build this? And then maybe if I have some time, I can write a few tests. But security is often an afterthought in this entire process, right? So what I thought like almost 6 or 7 months ago is like, hey, we've tried doing first, which is, so we try to build a lot of security tools, right? And we try to get developers to use them. We say you can use them in the IDE, you can scan, you can scan your source code, you have SAST, static analysis, security testing, you have DAST, and so on. But I think maybe the time is now for thinking about, rather than burdening developers with more tools, can we actually build tools that can do development tasks for security engineers? So we don't need developers to do some of this work, right? So that was kind of the backdrop of how we came to start Patched. Now, how many of you actually recognize what this is? Yes. So this is the how OWASP top 10 has evolved over the last 20 odd years. So the very first list came out in 2003. There was no list in 4, and these are the category of top 10 web application vulnerabilities. And like they publish they collect the data for a few years from vendors, and then every 3-4 years they publish a new list. The most recent one was in 2021, right? But if you look at it, and these arrows are a little hard to see, but despite a lot happened in the last 20 years in terms of how we build software. So from waterfall to agile to monoliths to microservices to DevOps to DevSecOps. Fundamentally, the kind of mistakes or vulnerabilities that developers introduce in the software have remained pretty much the same, right? So if you look at it, the ones in the dark are the ones which are repeated. So still, one of the major cause of vulnerabilities in software are injection, broken access control, and so on and so forth, right? So despite our best attempts, vulnerabilities or even vulnerability types are quite persistent, right? So, and this kind of leads us to this whole thing of this hamster wheel of scan and fix. And this isn't a term which I came up with. This was Chris Romeo, who runs a threat modeling startup and a very popular AppSec podcast. Who came up with this term last year, which is that we're stuck in this kind of a loop within application security, which is about, so we scan with some tools towards the end of the cycle, we find some vulnerabilities, we create some tickets, and then we add more work on the developers. They go ahead and fix them, and then it just continues, right? And there's a lot of talk about shifting left, right? So how we can actually help move security earlier in the life cycle. But it doesn't really help. It doesn't really help stop the cycle. It just starts it sooner, overburdening the developers, right? And putting it in the IDE, although in theory sounds nice, but in practice, it can lead to interruptions in developer workflows. So if someone is trying to write a piece of code and you constantly prod them with alerts about security or other issues, it can actually lead to compromising their productivity, right? So despite all these efforts, we are still stuck in this kind of a loop of scanning and fixing. And is there something that we can do today to actually help us improve the situation, right? So what we wanted to see was, and we've been, unless you've lived under a rock in the last 2 years, you've seen fundamentally a huge progress being made on generative AI and use of large language models. So the first question we started off with was like, hey, So that's great. We want to automate some of this to the as much extent as possible. How good are LLMs or how good are large language models today at fixing vulnerabilities, right? So that's the very first question we started with. And so if you're familiar with coding related LLMs, you'll always hear this term called human eval, which is a set of data set which was created by OpenAI for evaluating coding related models, right? So human eval is a small, I think 100 odd Python programs that people use to test. So what we did is first we went ahead and created a benchmark to evaluate these LLMs. We call it static analysis eval. So we restricted ourselves to only the kind of vulnerabilities that can be flagged through static analysis, right? So in particular kind of issues which I just showed, like OWASP top 10 like issues, right? And we created a data set of 76 Python programs. So they're all single files. Each of them have exactly one vulnerability, and they are based out of a scan of the top 1,000 projects on GitHub, right? And that vulnerability is a vulnerability detected by a particular static analyzer, right? So because if you've used SaaS tools, you realize not all of them report all vulnerabilities. There's a huge variance, right? So what we did is we used SendGrep, which is the open source static analyzer, and we created this data set. So the data set is available at the following link. And we evaluated a number of models. So what you see on the right hand side, although it's a little small, are all these models. They include open models also, as well as proprietary models, right? And we've done it for almost 6 months now. So the thing at the bottom here is actually GPT 3.5, okay? So like 6 months ago or almost 8 months ago, this used to be state of the art. But today, and this is like latest as of last week, you'll see on top is GPT 4.0, which is the latest model from OpenAI, and then the second one is Gemini 1.5 Flash, right? So even in this very, very simple setting, so I'm not in under delusion that we can solve all the problems, because in this very simple setting where each file, each code snippet is just one single file with a single vulnerability, you'll see that the best model today doesn't even reach like 70% accuracy, right? And the way we do it is we don't have any special prompts. We just take the input, we just write we give every model the same prompt, which just says like, hey, fix this particular vulnerability, so and so at this particular line, right? But at least there's been tremendous progress if you look at in the last year or so. So we do hope that eventually a large number of these kind of vulnerabilities would be able to be resolved by LLMs, right? So with this in mind, we set out to build open source framework that integrates and automates these kind of tasks. So vulnerability fixes is one. We do other kinds of things like dependency upgrades, secure code reviews, and so on. We call this framework Patchwork. And if I have some time towards the end of my talk, I'll give a live demo of this framework. But like you see, doing a single shot, just using one LLM, giving it a code snippet, and then expecting it to solve or fix vulnerability is not sufficient. So you can only reach like up to 70%, right? So what you really need is, and this is something people have discovered in other aspects, not just in coding, is that you need more agent-like workflows, right? So typically an LLM-based agent is something which has 3 or 4 main components. First, it has access to tools. So tools would be things like, in our case, scanners, CI/CD pipelines, QA tools. It can take certain actions. So in our case, we call them steps. It has access to some memory. So when it comes to coding, the kind of memory we're talking about is the actual source code. Maybe additional software artifacts like bug reports, documentation. And then finally, the way the agent works is there's a component called planning, where you actually orchestrate a plan to solve a particular goal. And that is what we do using a workflow-based system, which we call Patchwork. So Patchwork is just a blueprint that implements a generic agent-based LLM workflow in the context of coding, right? So this is kind of how it looks like. So we have some set of atomic steps, and these are the steps that we have created, but you can write your own steps. So steps are all related to coding tasks. So these are things like scanning a repository, committing code, putting a comment, creating a pull request, those kind of things, right? And these steps can be combined together in form of workflows. Again, we have some set of workflows that we have written, but you can actually combine and write your own workflows to solve a particular task. An example of a workflow or patch flow would be something what we call, for example, autofix, right? So in this, what we do is we have a series of steps. So the first step is to scan. So we scan using a open source scanner, SendGrep, or if you have your own SAS tool, we can just input the SARF file from the tool and then do the scan. We extract the CWEs, right? Then within the source code, we figure out what are the places where there are vulnerabilities. We use an LLM to generate the fix, and once we have the fix, we commit it, and then we create a pull request, right? But the point is that many of these steps are actually not things that they're quite common, right? And have nothing to do with the fixing, for example, committing pull request, scanning, and so on. So the idea is that these steps are something you can reuse across different workflows. And then once you have this set up, you can actually write your own workflows easily, right? So to run this, it's as simple as just doing patchwork, autofix, just giving it the SARF file, and then the prompts. Okay, we allow you to use any LLM because what we realize is that different LLMs have different capabilities, and in different situations you may want something else. So if you do not want your code to go out, or you host everything bare metal, you are a bank, you will want to use a locally deployed LLM, right? So even within Autofix, you can actually combine any SaaS tool, or you can combine any LLM or any combination of these by just changing the prompt and the settings, and then you can get the entire flow to work for it, right? So we did some small tests with some more realistic examples with respect to the autofix flow, just to see how different models perform. And there are at least three different axes along which you can think about. So one is obviously the accuracy, which is super important. But what is also critical is the time, which is the amount of time it takes to do or generate the fix, and the cost to do the fix, right? So when you compare across these three axes, you will see that although GPT-4 is the most accurate, if you look at the time and the cost, Llama 3 is not so bad. So that is actually Llama 3 running on Grok, which is a LLM inference provider, right? And the reason why the time becomes important is because when you're doing a complex workflow, you don't do just one call. You actually end up making multiple calls to the LLM. And if each call takes a huge amount of time, then you can't, there are certain workflows that will take too long for you to finish, right? So that's the reason why we support multiple LLMs, and even within a workflow, you may pick and choose an LLM depending on the task you're doing. Okay, so why go ahead and use this? Why can't I just build everything on my own, right? Which is kind of where we started. So the reason why you may want to use a patchwork or open source framework rather than build on your own is because it already comes integrated with the SDLC. So you can run it in IDE, you can run it in CLI, you can run it in your CI environment, you can call it from a GitHub action. So you don't have to do all those integrations. It already, like I mentioned, works in any LLM. So you can use any LLM over the API, or you can just even use a local running LLM. It's customizable with prompt templates, so we do ship with our patch flows with a set of prompts that we have worked on, but you can just change them. So these are like just JSON files, you don't have to write code to change the prompt. And finally, it already ships with a extensible library of steps, so we already have around 20-25 steps, which cover most of the integrations. So you don't have to write anything to, say, integrate into GitLab or GitHub or so on. All right, so are there any questions? Otherwise, I'll quickly jump into a demo and walk you through how one can use it. So I'll just pause for a bit here. Sure.
How does this, so you made a point earlier about if there's a copilot already built in, like Microsoft Copilot, and strong for
Yes.
developers. How does this, what's your demo going to show us how your product is?
Yeah, so what most of the people are focused on right now is actually things within the ID where a single individual developer is interacting with the LLM to do their own task. We are focused on the so-called the outer loop of development, which is everything that happens after you check in the code, right? So even though you can run it through ID, but now for example, so most of the tasks that what I will show are actually things you run in the pipeline. So these are things like either do code reviews or to scan a tool and then generate a fix. So all of our, and that's why I call it patch flow, because at the end it's always a patch or a pull request that can go back to a code for the developer to review. So we are focusing on the outer loop and all the workflows to automate that. Okay, so this is the, let me see if it's visible. So this is the open source repo. So you can actually install it using PyPy. So you can just do a pip install, or you can build it from source. Once you have it, the CLI is very easy to run. You just call patchwork, the name of the patch flow, and some arguments. So the common argument that you have to give is actually the API key and the model you want to choose, right? So by default, we default to GPT 3.5. So you have to enter your key. If you don't want to do that, if you want to follow along right now, you can get a free key from our app. You can just log in and generate a API key that will allow you to run it without putting in your own key. So let me just quickly show you one example with the CLI, and then I'll come back and show the app as well. So here I've already installed the CLI. You'll see that there are like two things. So one is something we call configuration, which is how you can separate different profiles. So let me just show you what configuration looks like. Right. So each patch flow will have some set of default configurations, which are like this. So they will be present in this YAML file. So this is, for example, for the flow that can fix SAST vulnerabilities, right? So there are some things related to the flow type, so vulnerability limit, context size. And then there's some basic things which are common. For example, what model you want to use, what is the base URL, what is your key, and so on, right? And in addition, each of the flows will have at least a prompt, right? So in this case, you'll notice that in the prompt we have some variables which are in double curly brackets. So these are actually templates which are filled in during the execution of the program. So the affected code is extracted from the output of a previous step, and then it is put here, right? So you can actually use those this way. Now let me just quickly run this, and I'll show you what I'm running it on. So I'll start with actually running a very simple flow which just generates a README, right? So I just do patchwork, generate README, and some config, right? So the example I'm using here is a sample app, so it's not something. So I just spoke from Veracode's example Python app. It just has a single main file. There is some vulnerability in it, and then it has some package manifest where also there is a vulnerability, right? So it's just, you can see the flow just finished. So these are the steps which are called during the execution of the flow. And in this particular case, at the end, it generated this pull request. And if you look at this particular request, it is this one. So you'll see that it adds one README, and the README would actually summarize the code. So there's this file, and it says there is, and actually figures out there's actually a security vulnerability in this particular piece of code, right? So this is just the one example where it generates the README. Now let's see if we can actually scan and fix this. So for that, what I'll do is I'll just use another flow which we were talking about earlier, which is autofix. So I just change this to autofix. And the first step here is it will actually do a scan, and by default we use open source SendGrep. So it will run SendGrep on the repository, and then it will identify the vulnerability, and then finally it will prompt the model to generate the fix. So you can see here, one thing you'll notice is we have this context strategies. So I just brushed over it, but every model that you do will have some sort of a fixed context for the input. And the code that you're giving in, if it is larger than that, you have to kind of extract the relevant pieces from it, right? So we have already implemented for all major languages different ways of doing it. So when it says full file, it means that the file itself was sufficient. Otherwise, in other cases, if the file is big, you'll see things like class, method, and so on. So we parse the AST, we have various ways of chunking it down so that it's relevant, and then we have a way to actually put it back together. So you don't have to do that. So it's actually generated a pull request. And if you look at this patchwork auto fix, you'll see that, okay, this fixes one issue, and it's the same issue that you saw in the, well, there's one additional thing, HTTP, but the issue was that there's a shell injection, so it changes it to false. If we look at the file that has changed, you'll see that it made the change, right? So similarly, we have other other patch flow. So the one of them which is we found very useful is actually a pull request review, where you can actually just give it a input as a URL to a pull request and then use an LLM to comment on it, right? So I'll just try to do that for this which we just created. Right. So I just I'm going to call a new patch flow called PR review. And what I'm doing is, as an input, I'm taking the pull request that was generated in the previous workflow, right? And I'm just going to call it with this arguments. And then you'll see some of the other steps which are called, so which is read pull request strips, prepare prompt, call LLM. And you'll notice that some of the steps are always common, which is another reason why it makes sense to use a framework like this. And now it has already finished, and you'll see that it created this particular comment. So it described what the changes were, right? Okay. Now, so we also have a workflow for doing one of the other common tasks, which is around dependency upgrades. So if you're using a third-party library or component in your tool, or you can do software composition analysis and figure out what are the vulnerabilities. So we have a patch flow for that. It's called dependency upgrade, which will take your. We use again an open source tool, OWASP DepScan, to do the scanning and to do the upgrade. Now this bumping up versions, that is actually quite common. It is also done by Dependabot on GitHub. But in addition, what we do is we actually try to migrate the code also. So here, this is an example patchwork which is created. So if you look, there are actually two changes. So the first is the package manifest file itself. So it bumped up the version from 2.4 to 2.6 because 2.4 was vulnerable, and request from 2.30 to 2.31. But between these two versions of request, the API has changed. And you will notice that it actually is able to migrate the code as well. So the rebuild proxies method is the one which has changed between these two versions of the requests, and the LLM is able to migrate this, right? Now, of course, how it does it, the intelligence comes from the way we have set up the prompts, right? So if you look at the prompt from dependencies upscale, you'll see that there are multiple prompts here. So first is just the one which does the upgrade of the package manager file. Then we have two additional prompts, get impact and migrate code. And when we do get impact, what we do is we actually fetch the source code of the library at the tags between the vulnerable and the fixed version, do a diff, and then summarize the diff using an LLM to figure out what has changed. We use that information as part of another prompt where we tell the model to see, given that these are the changes between the versions, can you migrate the code, right? So so this workflow actually does not only just the upgrade of the package manifest file, but also migrates the code along with it, right? Now, finally, I think I have like a minute or two. Let me just show you one last patch flow, which is, I don't know how many of you have heard about Devin, which was this demo which Cognition Lab had done recently. So final patch flow that we have is something which is similar to that. So this is called resolve issue. So what you can do is you can give any GitHub issue, and so this particular issue says, hey, add a new method in main.py, and there is some description of what you want to do. And then you can run this method, and the LLM will try to read the issue description, figure out what are the files in the repository that need to be changed, and then try to make the change itself, all in a series of steps. So let me just see if I can run this. Yeah, so this is the issue. So this is the patch flow which says resolve issue, and the input that I've passed is actually this, which is the issue URL, right? And as it runs, I'll just show you, I just ran it beforehand. So it figured out, first step is to find out what are the files that need to be changed. So it found out, okay, I need to make change in this file. And it also created a pull request, which is linked in the issue. And you'll notice that it would have actually implemented it. So the issue said that please add a health check, so that /health returns okay. And then it added this piece of code in the end. Right. All right. So that's pretty much it. I didn't have time to go through the app. So everything you can do here, you can actually do it from the app. So you don't have to use the CLI if you don't want. So you can just log in with your GitHub account. it installs an app. You can choose what repository you want to scan. So this is the same example file project. You can do patch. So things are a little easier in the app. So you have the same, all the 4 flows. You can choose which branch you want to apply it on, and then which scanner you want to use, and then just list patch, right? And it would do the exact same thing. It will trigger a new patch, and you can also access the pull request from here. So what I just showed you in the CLI, you can do all of that using the app as well. Okay, and like I mentioned, if you want to try it out, you don't need to put your own key. You can actually just use our key, which will give you free access up to 50 patch flows per month. So you can just generate a new key and use that instead of OpenAI key in the CLI as well. Alright, that's pretty much it. Thank you for your time, and do check out the repository, and please give it a star. Thank you.